Hi learners! On this video lesson, you will learn the angle addition postulate. It visually presents what angle addition postulate is, when to apply it, and how it is used. Applications of angle addition postulate in real life are shown to make the concepts relatable and meaningful. Strategies in analyzing and answering word problems related to the topic are demonstrated to let you gain an understanding on how these are done so that you will be able to successfully answer geometry problems similar to these in the future. If your lesson is on angle addition postulate, or if you have an assignment on this topic, or if you're preparing for a test in math or a test in geometry in particular, or you're someone who is interested in learning math, then this video is for you. Having that said, please support the channel by giving a like. If you have not already done so, hit that subscribe button and share this video as well. Thank you, it will definitely help this channel. To start, let us refresh our memories of what an angle is. Here's an angle. It has two intersecting rays and an opening between the rays indicated by an arc. The rays are the sides of the angle, and the intersection of the rays endpoints is the vertex of the angle. The opening corresponds to the size of the angle. A protractor is used to measure its size. Refer to the video lesson entitled Types of Angles based on measure on how an angle is measured using a protractor. On this video lesson, we will use the degree unit for angle measure. Remember that an angle has this notation. Now, naming 3 points on the angle as shown will allow us to name the angle. The angle can now be named as angle EFG, or angle GFE, or angle F. Note that when 3 letters as shown on the diagram are used, the vertex point must be at the middle. When angles are labeled this way, they are named as angle N and angle 1 respectively. Let us look at angle CAB here, learners. The angle has ray CA and ray AB for its sides and point A for its vertex. The space between the two rays where the arc is located is the interior of the angle. Thus, all points bounded by ray AC, ray AB, and its vertex point A are in the interior of angle CAB. In some cases, the interior space is marked with the name of the angle, maybe a number or a letter, or the measure of the angle itself instead of an arc. Let us identify one point in the interior of the angle and call it point D. Now, we will draw a ray from point A, the vertex, to point D. What do you see this time, learners? Okay, so now we see two adjacent angles, angle CAD and angle DAB. A detailed discussion of adjacent angles and other angle pairs can be viewed on the video lesson entitled Angle Pairs. Being adjacent, the angles are sharing a common vertex, point A, and a common interior side, ray AD, no overlap. Clearly, angle CAD and angle DAB form the original angle CAB. Thus, the sizes of the two smaller angles put together is the size of the original angle. What we have just described is what angle addition postulate is all about. A postulate is a rule in geometry that is accepted as true. So, the angle addition postulate states that if a ray lies in the interior of an angle, dividing the angle into two smaller adjacent angles, the sum of the measures of the two smaller angles is equal to the measure of the original angle, the larger angle. Using this figure, where ray AD is in the interior of angle CAB, angle addition postulate can then be mathematically written as the measure of angle CAD plus the measure of angle DAB is equal to the measure of angle CAB. In simple terms, it says that the sum of the parts is equal to the whole. Sounds like a common sense rule, right? I hope you were able to get it, learners. Angle addition postulate is used in finding unknown angle measures. Now, where do we see applications of angle addition postulate in real life? We see their applications in trusses. On the photographs, some of the angles on the trusses are marked for clarity. We see them in roof trusses, in bridges. We also see applications of angle addition postulate in other structures. How about you, learners? Can you identify anything around you where angle addition postulate is most likely applied? Okay, let us work on the sample problems that follow so you will know how to use the postulate in solving word problems. Here's the first problem. Given the diagram, find the measure of angle EHG if the measure of angle EHF is 70 degrees and the measure of angle FHG is 50 degrees. Option A, 20 degrees. Option B, 50 degrees. Option C, 70 degrees. Option D, 120 degrees. As usual, we begin by reading the whole problem and may read it several times when needed to know what we're looking for, to determine what are given, and to figure out how the given information help find what we're looking for. Okay, what is asking the problem, learners? The word problem is asking us to find the measure of angle EHG. What are given? A diagram is given with the measure of angle EHF, which is 70 degrees, and the measure of angle FHG, which is 50 degrees. Let us look at the diagram and put the given angle measures into it. Now, what type of angles are angle EHF and angle FHG, learners? You're correct. They are adjacent angles. They share a common vertex and a common side, no overlap, which means that they form to make the larger angle, angle EHG. Can you follow, learners? So, we can apply the angle addition postulate in answering the problem, which says the sum of the parts is equal to the whole. That is, the measure of angle EHF plus the measure of angle FHG is equal to the measure of angle EHG. Plugging in the values we have, adding 70 degrees and 50 degrees gives us 120 degrees. So, what is our answer, learners? Is it option A, option B, option C, or option D? Okay, so the answer is option D. That was easy. Okay, let us move on to sample problem 2. Here is the problem. Use the diagram below to answer the question. The measure of angle QSR is 60 degrees and the measure of angle PSR is 155 degrees. What is the measure of angle PSQ? Option A, 25 degrees. Option B, 95 degrees. Option C, 120 degrees. Option D, 215 degrees. As usual, we begin by reading the whole problem and may read it several times when needed to know what we're looking for, to determine what are given, and to figure out how the given information help find what we're looking for. Okay, what is asked in the problem, learners? The word problem is asking us to find the measure of angle PSQ. What are given? A diagram is given with the measure of angle QSR, which is 60 degrees, and the measure of angle PSR, which is 155 degrees. Okay, let us look at the diagram and put into it the angle measures that are given. Now, we clearly see the angle whose measure we are looking for. Learners, what can you say about angle PSQ and angle QSR? Okay, so they are adjacent angles. Being adjacent, they form to make the larger angle, angle PSR. So again, the sum of the parts, the smaller angles, is equal to the whole, the larger angle. That is, the measure of angle PSQ plus the measure of angle QSR is equal to the measure of angle PSR. Plugging in the values, we have subtracting 60 degrees from both sides of the equation gives us 95 degrees. So what is our answer, learners? Is it option A, option B, option C, or option D? Okay, so the answer is option B. That was again easy. Now, is angle addition postulate only confined to two adjacent angles? Let us look at the diagram here, learners. Here, angles 1, 2, and 3 are positioned side by side. They share a common vertex, and each pair of angles share a common side, the ray, no overlap. So they are adjacent. Clearly, the smaller angles, angles 1, 2, and 3, altogether form a large angle. If the large angle is angle 4, then the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to the measure of angle 4. So the answer to the question is no. While often demonstrated with two angles, the postulate applies to any number of adjacent angles that form a larger angle. As what you have seen, the postulate is used to determine the unknown measure of the large angle as shown in sample problem 1, and is also used in determining the measure of an unknown smaller angle as shown in sample problem 2, where the measure of the large angle, the whole, is known. Having that said, it will be helpful to remember some relationships between the large angle and the smaller angles forming the large angle based on position and measure. Look at the diagram here, learners. Here, angles 1, 2, 3, and 4 are adjacent angles. That is, all the angles share a common vertex, and each pair of adjacent angles share a common side. Now, the non-common sides of the adjacent angles form a straight line. Recall that the angle formed by rays forming a straight line is a straight angle whose measure is 180 degrees. So here, the smaller adjacent angles, angles 1, 2, 3, and 4, form a large angle, the straight angle, whose measure is 180 degrees. Can you follow, learners? Applying the angle addition postulate, which says that the sum of the parts is equal to the whole, we can then write this equation about the diagram. The measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 is equal to 180 degrees. So, if the measure of one of the smaller angles is unknown, the angle addition postulate, which states that the sum of the parts is equal to the whole, is definitely applicable. Another thing, if two or more adjacent angles surround a point without overlap as shown, the measure of the large angle, which is the whole, is 360 degrees. So again, if the measure of one of the smaller angle is unknown, the angle addition postulate is also applicable here. Thus, using the diagram, we can write the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 plus the measure of angle 5 is equal to 360 degrees. As you see, angle addition postulate is versatile, for it works for any configuration of adjacent angles that build up to a single larger angle. Let us do this next sample problem. Here is the problem. Using the figure below, find the measure of angle 1. Option A, 40 degrees. Option B, 85 degrees. Option C, 135 degrees. Option D, 240 degrees. As usual, we begin by reading the whole problem and may read it several times when needed to know what we're looking for, to determine what are given, and to figure out how the given information help find what we're looking for. Okay, what is asked in the problem, learners? The sample problem is asking us to find the measure of angle 1. What are given? A diagram is given with some angles having measures. Also, the angles are adjacent, surrounding a point, the vertex, with no overlap. Okay, let us examine the diagram further to get more information. We know that the angles are adjacent and surrounding a common point, the vertex. With that configuration, we can conclude that the smaller adjacent angles form a larger angle with a measure of 360 degrees. Can you follow, learners? Therefore, we can say that the sum of the parts is equal to the whole. Thus, the measure of angle 1 plus 95 degrees plus 105 degrees plus 120 degrees is 360 degrees. Adding 95 degrees, 105 degrees, and 120 degrees gives us 320 degrees. Subtracting 320 from both sides of the equation gives us this. So, what is our answer, learners? Is it option A, option B, option C, or option D? Okay, so the answer is option A. That was very easy. Let us move on to sample problem 4. Here is the problem. Two angles are supplementary as shown. The measure of angle 1 is 2x plus 3 degrees, and the measure of angle 2 is 3x minus 8 degrees. Supplementary angles are any two angles whose measures sum to 180 degrees. Part 1, find the value of x. Option A, 37. Option B, 57. Option C, 77. Option D, 97. Part 2, find the measure of angle 1 and angle 2. Option A, the measure of angle 1 is 37 degrees. The measure of angle 2 is 77 degrees. Option B, the measure of angle 1 is 77 degrees. The measure of angle 2 is 90 degrees. Option C, the measure of angle 1 is 77 degrees. The measure of angle 2 is 103 degrees. Option D, the measure of angle 1 is 103 degrees. The measure of angle 2 is 180 degrees. As usual, we begin by reading the whole problem and may read it several times when needed to know what we're looking for, to determine what are given, and to figure out how the given information helps find what we're looking for. Okay, what is asked in the problem, learners? Sample problem 4 has two parts. In part 1, the problem is asking us to find the value of x. In part 2, it is asking for the measure of angle 1 and angle 2. What are given? We're given a diagram with a pair of supplementary angles. We are also given two algebraic expressions representing the measures of angle 1 and angle 2. Let us label angle 1 and angle 2 on the diagram for clarity. We will start with part 1, asking for the value of the variable x. Since the two adjacent angles are supplementary, the two smaller adjacent angles form a larger angle whose measure is 180 degrees. Thus, we can apply angle addition postulate, which says that the sum of the parts is equal to the whole. That is, the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. Plugging in the expressions for the value of angle 1 and angle 2, we have putting the degree unit on each measure on the left side of the equation gives us combining 2x degrees and 3x degrees gives us 5x degrees. Adding 5 degrees on both sides of the equation gives us 185 degrees. Dividing both sides by 5 degrees gives us 37. So, what is our answer, learners? Is it option A, option B, option C, or option D? Okay, so the answer is option A. Now, we move on to part 2. Here, the problem is asking us to find the measures of angle 1 and angle 2. We start by writing the given expression for the measure of angle 1, which is, next, we plug in the value of x obtained earlier. Multiplying 2 and 37 gives us 74. Adding 74 degrees and 3 degrees gives us 77 degrees. Did you get it, learners? We now solve for the measure of angle 2. We start again by writing the given expression for angle 2. Plugging in the value for x, we have multiplying 3 and 37 gives us 111. 111 degrees minus 8 degrees gives us 103 degrees. So what is our answer, learners? Is it option A, option B, option C, or option D? Okay, so the answer is option C. Now, how do we check if the measures of the angles are correct? We do that by going back to the angle addition postulate, which says that the sum of the parts is equal to the whole. That is, the measure of angle 1 plus the measure of angle 2 is 180 degrees. Plugging in the values obtained for the measure of angle 1 and angle 2, we have adding 77 degrees and 103 degrees gives us 180 degrees. Thus, the sum of the parts is equal to the whole indeed. There you are, learners. That was again easy. I hope that you acquired lots of learnings in today's video. Let us summarize what we have learned today. We have learned that, first, angle addition postulate is a rule in geometry stating that if a ray lies in the interior of an angle, dividing the angle into two smaller adjacent angles with no overlap, the sum of the measures of the two smaller adjacent angles is equal to the measure of the original angle. Second, angle addition postulate, in simple terms, means that the sum of the parts is equal to the whole. Third, angle addition postulate is used in finding unknown angle measures. Fourth, angle addition postulate applies to any number of adjacent angles that form a single larger angle. Fifth, when solving a problem, you must read it and may read it several times when needed to know what you're looking for, to determine what are given, and to figure out how the given information helps find what we're looking for. Sixth, when a figure is given, make use of it and modify when needed. It is there to help you analyze and solve the problem. There you are, learners. I hope this video helps. That's it for now. If you have any questions, leave a comment below and don't forget to like, subscribe, and share this video to your peers so others will learn too. Bye.